So now I've completed setting up some of the other controls in the face. I've added one for the top lip. It pulls on several joints, even the one up here in the cheek just a little bit, the one just underneath the nose, and two across top of the mouth. Same with the one below. It's pulling now on the ones on this side of the face. I haven't hooked up the left side of the face at all to it, as I'm going to show you how to mirror some of these controls over and reset some of this up. One for the cheek now handles the cheek and underneath the eye a little bit, moves some of those around, and of course the mouth and the side of the face here that we had before all working. You can see getting this nice flexible face system go to work. It's quite interesting actually seeing it work without all the geometry on there and see it all deform and flex. And this is looking pretty nice. We're getting a pretty flexible looking face setup. A couple things we're going to do to complete this basically is one, we have to do the left side first off. So let's figure out how to actually set all this up on the other side so it's exactly the same. And part of the issue we're going to have with this is that you know, if we don't get this exactly the same, we'll get completely different results. And we've been just arbitrarily rotating some of these control points and some of these control objects to be able to set up the other side. So what we need to be able to do is we need to be able to somehow mimic these rotations on the other side of the face and make sure that they are exactly as we would expect them to be. So what we can do to do that is we can use a little bit of script, and we can use quaternion values. And most people don't understand quaternion rotations completely. The way quaternion rotations work is not like an Euler rotation. It isn't an XYZ value. It is an XYZW value, but the XYZ is not what you would expect in most cases. I'll give you a bit of an example of what a quaternion looks like. There is more information on my website about how they actually function and work, so you can read that as well. Let's pretend we've got a sphere, and let me just make sure it's sitting at 0, 0, 0. And let's say that we have a pointer that sits at 0, 0, 0 as well in this case. Height. Let's make it touch it. And I'm just going to make this transparent, see-through, just as for our example here. Go back and I want to grab the cylinder. A quaternion value is based on the point at which that cylinder touches the sphere. So when you rotate an object, you're not actually getting a rotation value XYZ here. What you're getting is that point on the sphere there, which has been normalized. So it is based on that position, and this pointer points at that position on the sphere somewhere. This is why you can't have function curves quite the same as you can with an Euler, because you really can't wind it up. You sort of have 0, 0, 0. You have the opposite side of it, which is at the bottom, and as you come back up, you go right back around to 0, 0, 0. And essentially, you can never have values that represent anything more than a unit vector. And that unit vector is the distance between the center of the sphere to the point on the sphere. So you can't have the XYZ values of a quaternion can't actually go higher than a value of 1 in their length in a unit vector. The fourth value is actually this value. It's the twist around, and it's a value from 0 to 1 that represents the rotation, basically the twist around that vector. And that is what a quaternion is based off of, and how it works. Now the advantage of it is it's actually better math. It's actually more accurate. Euler values are very inaccurate math for all intents and purposes. They don't really represent a good way of dealing with rotations in 3D space. They are great for animators because they have function curves. However, they are prone to problems like gimbal locking, as I'm sure most people have run into at some point. Quaternions don't run into that problem. However, they run into other issues like not having function curves. And so there's good points and bad points. You need to know when to use which ones. For mirroring a rotation,